Okay, in the question, in the wording of the question, I'll just show you guys quickly. They've listed various things here. They've said that AB is 50 millimeters, but that is on the picture. BC is 80 millimeters. So I'm not going to write all of this stuff down because everything is actually on the picture. Okay, so we'll just draw the picture and then we're going to answer the questions. Actually, guys, my ink is like drying and stuff, so I'll just put this picture up and you can just copy it from the worksheet. You don't have to write any of the stuff down, just draw the picture, please. Okay, I'll just put mine up quickly. All right. I do want you guys just to write that next to your picture because that is information that's very important. Okay, so please just write there that ABCD is a parallelogram. And then the first question, I'm just going to write that down. Now, guys, there was one piece of information in the listed stuff that actually isn't on the picture. Okay, so I just want to reiterate, when you are getting a diagram and it looks like there's a lot of stuff on this picture, all right? So I wouldn't blame you if you looked at it and you were like, okay, all the information is there. Please read through the sentences that they've also wrote down. So I didn't copy all of it down now, but let's just quickly go through it. Parallelogram ABCD. So there they're telling you that it's a palm. Hey, that it's a parallelogram. Has AB equal to 50 millimeters. Did they fill that in? Yes. BC equal to 80. We can see that that's also filled in. And angle BAD, so BAD, so that angle there is 110 degrees. They filled that in as well. E is a point on AD. Now we can see that, hey, AD is the line and then E is a point on that line, such that AE is equal to AB. AE is that part there and AB is that part. Is that indicated at all? No. So we need to actually fill that in, hey? So let's do that. So AE is equal to AB. And guys, they told us what AB was. Hey, they told us that it's 50. So AE would also have to be 50 millimeters. So you can actually fill that in also. We have the actual length. We know that they're equal, but we also know that they would both be 50 millimeters. And actually, guys, if you don't have this information, there's no way of doing the very first question. Okay, so please, it's very important that you read through that paragraph and you fill everything in. And then the last thing that they said is that BEC is 75 degrees, and we have that on the picture. Okay, 2.1, they're asking us to find E1. Now, guys, before we actually look at what they're asking, I want us to take a different color pen if you have, or if you worked in pencil, maybe use pen now, just to make it clear that we're adding stuff now. The fact that they told us that it's a parallelogram means that we can assume that this shape has all the properties of a parallelogram because they're telling us that it is one, hey? So even though they haven't filled in that the opposite sides are parallel, for example, we know that they are because it's a parallelogram. Does that make sense? So please, on your diagram, put a star, oh, it's not a star, an arrow somewhere on the top line and then an arrow on the bottom line to show that those two sides are parallel. So we can use that, guys. If we need to find angles, if we need to use a Z shape maybe there, just because they didn't put the parallel thing in, doesn't mean that we can't use the fact that those lines are parallel. Okay, they're telling us that it is a parallelogram, so we can use all those properties. Yes, Jamie?
If you were given a diagram of a parallelogram and the sides clearly weren't parallel, but it was labeled as a parallelogram, still
yes, yeah, you would still be able to use those properties. Yes. So that's why we always say that the diagrams are not drawn to scale. Okay. Okay, so can use all the properties. Please add that there. Okay, so we fill that in. We can fill it in for A, B, and C, D as well. So I'm going to do 2 arrows on A, B, and 2 arrows on C, D. And guys, we might not need to use it, okay, but we might. So it's better to have all the information at the beginning, then we know exactly what's going on. Now we know that the opposite sides of a parallelogram are also equal, right? So if AB is 50, what is the opposite side to AB also going to be? Okay, if that's 50, then this is also 50. Okay, so we can also put one line there to show that it's equal to that one. And we can also actually put that length there, 50 millimeters. But it's the same for the top and the bottom sides as well. Hey, if this whole side is 80 millimeters, then that whole side will also be 80. Right? Opposite sides of a parallelogram are equal. Now, guys, we know that that part is 50. So what must that one be if this whole side is 80? Jordan? 30. Okay, so DE is 30 millimeters. We can fill that in already. Okay, the whole side must be 80 because these two sides are equal. What else do we know about a parallelogram? What do we know about the angles of a parallelogram? Yeah? The opposite angles are equal. Hey, so if that is 110 degrees, then this whole angle, angle C, C1 and C2 together is also 110. Okay, we don't know what C1 is and what C2 is separately, but we do know that that whole angle altogether is 110. Let's do a thing there as well to show that those two are equal. And guys, we know that because the opposite angles of the parallelogram are always equal. Okay, and then in the same way, we don't have any information about the sizes of these angles, but we know that angle B, so let's use two things like that, will be equal to angle D. Okay, now guys, a parallelogram has one final property, which has to do with the diagonals, and that is saying that the diagonals bisect each other. But did they draw in the diagonals in this case? We have two lines here, but do we see that these two lines actually aren't the diagonals? Remember, a diagonal goes from one vertex, so one of the corner points of a parallelogram or any quad, to the opposite vertex. Okay, so if we had a line going from A to C, that would be a diagonal. And a line from B to D, not to E like we have here, but from B to D, that would be a diagonal. So guys, since they haven't drawn in the diagonals, we're actually not going to need them. All right. They will give you all of the lines that you need for these questions. So that last one, we're not going to fill in. Okay, so guys, do we see that we actually have quite a lot of information here, more than we thought in the beginning, just because we know the properties of a parallelogram. Okay, now let's move on. We're going to find E1, which is this angle over here. E1. Now guys, do we see that we have a triangle here? Triangle ABE. We have that 110 degrees. Do we have B1? Do we know what B1 is? No, hey, we don't know the size of B1. What kind of triangle is this though? If I'm literally just looking at that triangle on its own, I'm ignoring everything else. What kind of triangle is that? Sipe? It's an isosceles triangle. Do we see that? AB and AE are equal. And what do we know? If these two sides are equal, then what else will be equal? Those bottom angles, hey? The angles opposite those sides will be equal. So angle E1 is actually going to be equal to angle B1. Right? Because this is an isosceles triangle. We still don't know the size, but we do know at least that E1 will be equal to B1. Let's write that down, guys. That is some information that we can write down. Now, this is important. You have to always use reasons. See, they've even said with reasons. Now, can anyone remember the reason for that? If you know the two sides are equal, what's the reason for those angles? Do you have an idea? It's quite a funny one. Liam, do you want to try? Naomi? Hey, do you want to try? Not? Any guesses? Angles, opposite, yes. Equal sides, almost, very close. Okay, angles, opposite, equal sides. Do we see that that's what we have? These two angles are opposite the equal sides. Okay, so the reason there is angles, opposite, equal sides. Guys, you will already get a mark for saying that. Okay, we haven't even done any working. We haven't worked with any values, but just the fact that you can recognize that this is an isosceles triangle, so those two angles will be equal, and having your correct reason, that will give you 1 mark. Now, guys, this one is a bit difficult because they didn't tell us what B1 is. Okay, if they told us what B1 is, it would be easy. We could just say that E1 is the same. Now what they've done is they've only given us one of the 3 angles. Do we see that in this triangle? We know that all 3 of these angles must equal 180 when we add them together. We only have 110. So guys, what must these 2 angles be equal to together? Those 2, for these 3 to be 180. 70, hey, do you understand what I'm saying? So if we have 110 and then we still need 70 degrees to make these 3 equal to 180. All right, so let's quickly write it down like this. We're going to say E1 plus B1 must equal 70 degrees. Because what must all 3 angles add up to? 180, and I already have 110 degrees there. So what's left? What is 180 minus 110? 70. Hey, that's where that 70 comes from. Right, you can write it there at the top, 180 minus 110. That's where that 70 comes from. So I know that those two angles together must equal 70 degrees. Now guys, what is my reason going to be for this? What do you think? How do I know that the three angles in a triangle must add up to 180? Yes, angle sum in triangle. Now guys, if I know that E1 and B1 together must be 70, but I also know that they're equal, what must they be? Divided by 2, hey? Does that make sense? If I know that E1 and B1, they are equal to each other and they must add up to 70, I can just say 70 divided by 2 to get that. Okay, so let's write that. Therefore, E1 is equal to 70 over 2, or you can write divided by 2 if you want. And guys, for that, we actually don't need a reason. We've already written the reason down. Okay, the reason for this is just we know that they're equal, but we've already written that down there at the top. Okay, and what is 70 divided by 2? 35. Let's see, would that work, guys? If this one is 35 and that one is 35 and that is 110, will they add up to 180? What's 110 plus 35? 145 plus 35 is again 180. Okay, now guys, we know what these are now, so let's fill in their values. And I please want you to do that when you're doing these geometry questions. Whenever you're calculating something, put it on the picture, you might use it again. Right, so it's quite useful if everything is there. Okay, that was 2.1. 2.2 is wanting us to calculate E3. Okay, so E3 is that one over there. We have E1, we have E2. Can I find E3 using that? What do angles on a straight line add up to? Jordan? Also 180. Hey, so E1 plus E2 plus E3. These three altogether should equal 180. And I have those two, which is quite nice, hey? So what must I do? I'm just going to say E3 equals. Yes, 180 minus 75 minus 35. So 180, because these three angles are on a straight line and they should equal 180. And then you just minus the two that you have already. Okay, to get that third one. What is that reason, guys? Angles on a straight line. Okay, now you would probably be able to use your calculator if it's a geometry test, but let's see if we can do it in our heads. I don't want to confuse you though. If you're struggling with this, then don't stress. But what is 180 minus 75? 105, all right? And then we minus 5 from it, which is 100. Minus 30 is 70. Okay, so E3 is 70 degrees. And then we can write that in again. Right, we might need to use it later on. Did you see, guys, we actually had to use our answer to 2.1 to get the answer to 2.2. Okay, so that's why I said it's useful to actually fill it in as you're calculating. Okay, 2.3, what's the next one? We need to find angle D. Okay, now guys, angle D is this angle over here. Okay, we need to find that angle. Now guys, I know that geometry is difficult because you often don't know where to start. Okay, you don't know, must you work in a triangle? Must you work in the whole thing? Where must you work? So my advice would just be to try out various options. Okay, so if we're looking for angle D, do we see that again? We have a triangle here. Now we could possibly work in the triangle and say 180 minus the other two angles. I have that one, but do I have C1? No. Okay, so for this one, and we also now don't have an isosceles triangle like we had for the first triangle. Do we see that? Because in the first triangle, we had a similar situation, but because this was an isosceles triangle, we didn't actually need that one to calculate the third one. Here, is this an isosceles triangle, guys? If I have 30 millimeters and 50 millimeters? No. Okay, so I can't say that those two angles will be equal and then calculate the third one. All right. Did we or do we remember that angle B is equal to angle D? Why did we say that again? Because this shape is a parallelogram, hey? So guys, could I possibly calculate angle B? Because if I can get angle B, then I can just say that D is equal to that. Let's look at what I have in angle B. I have B1 is 35. Is there any way to find B2? Hey, what shape do we see, Naomi? We see a Z shape, hey? Do we notice that? Look at that. There's a very clear Z shape here in this triangle. And we know that these sides are not in this triangle, sorry, in this parallelogram. We have a Z shape there. We know that these sides are parallel. Hey, we filled that in at the beginning. So this angle is going to be equal to that angle. Look at the Z shape. Do we see that? So that 35. So this one is also 35 degrees, guys, B2. Because of the Z shape, because of alternate angles. So what is angle B, the whole angle, equal to? 70. So therefore, D is also going to be equal to 70. Okay, but now we must write all of that down. Right, and that's usually where, where the problems start coming in. Okay, so let's take it step by step, guys. The first thing that we did was we said B2 is equal to 35, right? Because we already had B1 from the previous thing. Okay, so we don't have to rewrite that again. B2 is equal to 35 degrees. Write that down, please. How did I know that? What shape did we have? That Z shape, hey? And that is alt angles. Good. But alternate angles, the lines, they have to be parallel for us to say that they're equal. So which lines are parallel here? And BC. Good. AD is parallel to BC. But was that given? Did they draw the arrows in or did we draw the arrows in? We drew them in. How did we know that we could draw them in? Because it's a parallelogram. So guys, you have to add an extra reason here, which is quite strange. We've never had to do that before. Just because the arrows weren't there, we knew that because this is a parallelogram, those lines are parallel. So you have to actually say opposite sides of, and then instead of writing out the word parallelogram, which takes quite long, you can use this symbol. It's two parallel lines and a little M at the top. Okay, you can use that for parallelogram. Right. So guys, this is something new. That's something that you haven't had to do before. Right. Now guys, if you forget that, you might lose this whole line because they will say, you couldn't say that they're parallel if you don't know that it's a parallelogram. And then if they're not parallel, then you can't use alternate angles. Okay, so please underline this or highlight it or something. It's coming from up there, the properties of a form that we're using, the properties of a parallelogram. Because guys, remember in a test or exam, this is on your question paper. Hey, I'm not going to see this. You don't hand in your question paper, right? So whatever you're using, you have to actually write down. And even if you do hand in your question paper, we still need to see this reason. Okay, so please, that's important. Yeah. You can, yes, but then again, we don't actually look at the picture when we're marking. We look at the reason in words. Yeah. Sure. Okay, guys, so let's get back to this. So we got that B2 is 35. So what does that mean? Angle B, the whole angle, is 70 degrees, right? We all fine with that? 35 plus 35 is 70. For this, we don't have to write the reason, guys, because we're just adding two numbers. Okay, that's nothing geometrical. That's just 35 plus 35. Therefore, angle D is also equal to 70 because of opposite angles of a palm. And that's the reason, okay? Opposite angles of parallelogram. Okay, 2.4 is a bit of a silly question. They're wanting us to find AE, so the length of AE. And if you look at your picture, what is the length of AE there? We filled it in already. 50, right? So that's the answer, guys. AE is equal to 50 millimeters. And how did we know that? You could say given, but let's be a bit more, let's say, just give a bit more information, because they didn't actually draw this line in on the picture. Hey, we drew it in, but what made us draw it in? Remember, that was what was in the wording here. They said AE equals AB. All right. So technically it is given, yes, you're correct. But let's just write a little bit more. Let's say given AE equals AB. Or even if you just wrote AE equals AB, that would be fine. Okay, that's a nice one. That's the answer for 2.5 or 2.4. And then for 2.5, they want the lengths of the sides of triangle CED. Now, guys, I actually forgot to fill in this answer to angle D on the picture. Let's just quickly do that. Angle D was also 70. So they're looking for these three sides, hey? That one, which we've already said is 30 millimeters. That one, which is 50 millimeters. And then they're looking for this one as well. They want the sides of this triangle. Okay, so all three sides. Now, guys, the 30 and the 50, why did we say that they were 30 and 50 again? Yes?
Because slide 8, you know, that is equal to, and
Yes. Okay, so guys, basically we know that these two sides had to be equal because it's a parallelogram, right? And then we knew that these two sides have to be equal also because it is a parallelogram. So for the 30 and the 50, we can write the same reason. Okay, so let me show you how to do that quickly. So we can say DE is equal to 30 millimeters and CD is equal to 50 millimeters. And for that, we can just say opposite sides of parallelogram. Okay, that was one of the properties of the parallelogram right in the beginning. We said we know that the opposite sides must be equal. So we could use that to get these lengths. Now for the last one, for CE, this is a bit more difficult. All right, we can't now use opposite sides of a parallelogram to get this one because this one isn't a side of the parallelogram. So we need to look in this triangle maybe if we have enough information to get that side. Now guys, is this a right angle triangle? Do I have a 90-degree angle anyway? No. Okay, so if we had a 90-degree angle, we could possibly try and use Pythagoras, all right? But in this case, we don't have 90. What do we have though? 70 and 70. I want to hear from someone else. Yes, Jordan? It's again an isosceles triangle. Do we notice that? Because we have that angle is 70 and that angle is 70. And if these two angles are equal, what does that mean for these two sides? They're also going to be equal, all right? Because this is an isosceles triangle, yes. So this is an isosceles triangle, guys. So what is CE going to be? 50. CE is equal to 50 millimeters. And the reason for that is sides opposite equal angles. Because now we know that the angles are equal, and that means that those sides will be equal. Okay, so you have to write it like this. Sides opposite equal angles. Okay, guys, I was going to work through question 3 as well. We don't have enough time. I want to give you some time to work in class. So I want you to do question 4 on your own. I will put it on the board now, and you can copy down the picture and the questions. But again, I will post it on Google Classroom for you. Are there any questions on this one? Now, guys, like I said, geometry is quite difficult once you have to start working out various things because there's so many things that you need to look out for. All right, but if they're telling you what kind of shape it is, please do what we did for this one. Fill in all the information that you know, all the properties that you know, right? That maybe aren't given. So if we're looking at question 4, again, they're saying ABDE is a parallelogram. So this whole thing is a parallelogram. So again, you can fill in opposite sides parallel, opposite sides equal, opposite angles equal, all right? All the stuff that we filled in for the first question, you can fill in for this one as well. The difference here is that they didn't actually give us any lengths of the sides like they did in the previous one, but they're telling us that these two sides are equal. Now, guys, what does that mean? If those two sides are equal, then those two angles will be equal. Okay, so that's something that you can fill in right from the start. Even if you don't know what those values are, you at least know that they will be equal. Right, and what about here? We have an isosceles triangle here as well. Do we see? Those two sides are equal, which means those two angles will be equal. So there I've already given you the answer to A. A is going to be 28 degrees. Okay, because of angles opposite equal sides. So for question 4.1, they're asking you what kind of triangle is triangle ECD? We've already said it. It is an isosceles triangle, right? And then work out, giving reasons, the sizes of angles A, B, C, D, and E. So I've already told you what A is. A is 28. Then once you have that, you need to find B. Then you're going to find C. Then you're going to find D and then E, right? You have to do it in this order, please. Okay, and that is your homework for tomorrow. So I will zoom in a bit here so that you can work from the board. But then if you don't finish in class, guys, you're going to have to finish it at home, please. So I'll post it on Google Classroom as well. All right, get going, get going.